Hi everyone, welcome back to our YouTube channel Electro Study. This is lecture series 17 under computer networks dealing with IP version 4 Classful addressing. Come, let's go into the video. Please do like, share, subscribe and comment. So what is Internet Protocol version 4 address? Generally, IPv4 address, they are unique. That is, for each address, it defines one and only connection to the internet. So if a device has two connection to an internet, like if it is using two or three networks for establishing two connection to the internet, it has two IP version 4 address, that is 2 IP address. In IPv4 address, these are universal, that is, we tell that it is universal, that is, the addressing system must be accepted by any host that wants to be connected to the internet. So, this is the connection of each of the device to the internet. We should have a particular address, IP address, that is internet address with us, right? So if you connect to a Wi-Fi, your mobile or device, whatever you are using, it is having a particular IP address, and also the router will have its own default address. So the address formed is a 32-bit address that defines the connection of the host or the router through which the net is connected, internet is connected. This address, whatever it is specifying, it is the address of the connection and not the address of host or router what we are using. So for this, you need a address notation, or how we have to know how these addresses are formed. So under address space, the complete address space will be used by each of the protocol in that particular layer. Now, if a protocol is using n number of bits for defining an complete address of a device, that address space will be denoted by 2 to the power of n. That is, when n is the 32 bit, then it will be represented as 2 to the power of 32. So it is coming to a conclusion that IP addresses uses 32-bit address format, and what happens is, see here, the address space is 2 to the power of 32, which is this much amount of bits can be shown in an address space. Got it? Next, there should be some notation that has to be followed for writing an address. Now, this notation will be divided into two types, that is binary notation and a dotted decimal notation. So there are three common notation generally to show the IP addresses, like binary notation, dotted decimal notation and hexadecimal notation. Generally, in binary notation, what happens is this IP address is displayed as a 32-bit. That is, see here, 1 byte we will tell as 8 bits. So 32-bit in the sense like this, 8-bit, 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 8-bit. So totally it is 32-bit. So after each byte, after 8 bits, there should be some space provided. After next 8 bits, there should be some space provided. So this is how binary notation will be looking like. In dotted notation, what happens is it is written in a decimal form. That is, this binary notation, if you calculate the decimal of this binary notation, it is 128. So the space will be calculated here as a dot. So that is why it is called as dotted decimal. So each of the bits with the separated with the space, they will be taking their particular decimal values, and each of these decimal values will be separated by dots. So this is dotted decimal. These two are the main thing that we use for forming an IP address. There is another format, that is hexadecimal format. From this you will be deriving the hexadecimal format of the dotted decimal. So it will be represented like this. Actually, we don't use this kind of format, only maximum this format or this format we will be using. Next is hierarchy in addressing. So there should be, see, whenever, say for an example, when there is a telephone number, we are maintaining an hierarchy for each and every country. Say suppose if it is India, it is plus 91 followed by 10 or 9 digit numbers. Right. So for different countries, you have an hierarchy that should be followed with its country code followed by the phone numbers. Likewise, in postal address, there is a hierarchy that is being followed. That is from the when you're sending a package or when you're sending a message through a letter, the sender has to write the from address, to address, post it, and it is sent to the receiver without any change of content. So there is a hierarchy that is followed. If it is a register post, only when the receiver signs in the particular form, it is registered that the package is received by the sender. So the post office is following some hierarchy to send the packets from the sender to the receiver. So same wise, to define a network, there is a hierarchy. That is, the complete bits, 32 bits, is divided into two. That is prefix and suffix. So prefix is nothing but it is n bits, and suffix is nothing but it is, if it is a 32 bits, 32 bit minus the n bit. So here the prefix will be of fixed length or variable length. It can be 8 bits, means only 8 bits, or you can keep on varying the value of n. Now this prefix will be completely defining the network, and this suffix will be defining the connection of nodes. So this is the complete network, and to which node it is connected, it will be defined by the suffix. So this is the hierarchy in addressing. Next, in classful addressing, that is under this IP addresses, there are two type of addressing. One is classful addressing that we are seeing now. In the next video, we will be seeing about classless addressing. So in classful addressing, what happens is the complete area is divided into, complete address space is divided into 5 classes: class A, B, C, D, and E. So what happens is, in class A, there are 4 bytes. That is, one byte will be having 8 bits stored in its space. Now, this is divided into different classes, and what happens in class A is, if the first digit is filled with 0, so there is a capability for the data has to be stored. So 0 to 127. So this class A has the capability of storing 128 bits. Being first is 0, we are telling that 0 to 127 bits, it can occupy in one space. So the same space is followed for all the other bytes. If it is class B, then if the number is starting with 10, 1, 0, then what happens is, see here, if it is class A, number of networks you can connect is 128. So 128 is the number of hosts 2 to the power of 7. That is, here in class A, the network length will be 8 bits. But first bit is 0. So we are taking 0 to 7, which is constituting 8 bits. So 2 to the power of 7, what is that? 128. So 128 number of networks is connected. So when you form this, the value will come and the number of hosts will be this much, 2 to the power of 128. Next, in class B, complete length is a 16 bit. In that 16 bit, first 2 digits will be 10. If it is 10, it belongs to class B. Now, when you are excluding the first 2 digits, it will become 14 bits. So 2 to the power of 14, it forms this number. So this much number of networks can be connected, 16,384. Same wise in class C, what happens? The network length is 24 and the first 3 bits will be 110. Whichever bit is starting as 110, it is under class C, and excluding this first 3 bits, it will become as 21. So 2 to the power of 21 gives a particular number. That much number of networks can be connected in class C. And class C and class D and class E, what happens is, it is not divided into prefix and suffix. So there is no casting of address that is taken place. So now if you see here, the different classes have multiple number of bits to be stored in the address space. But we are not using classful addressing, telling that there is an occurrence of address depletion. This is the disadvantage. what happens is each and every class having n number of bits to be occupied in it, not all these spaces completely occupied. Say suppose, see here, only 8 bits is occupied here and all others remains unoccupied. What happens? There is a formation of address depletion. It is unoccupied, so it is not good for the system to be performing well. So because of this address depletion, as a reason, classful addressing was said that it is not sufficient, and we moved into classless addressing. So to improve that, we were using subnetting and supernetting. That is, to elevate this address depletion, these two strategies were formed. That is, in subnetting, what happens is, if a class A or class B is divided into several subnets, see, like different bits is stored in different nets. So each of that subnet will be having larger prefix length than the original network. Say for example, I will tell you, if you're considering a network in class A and it is divided into 4 subnets like this. You're considering class A, 4 subnets it is divided, and each of these subnets will be having some prefix value that you will be equating to 10. That is, if that value is equal to 10, then this address space will be filled, or else it will be left unoccupied. So if the supernetting process and subnetting process was followed. Though it was followed, there were some reasons why there was no successful classful addressing we followed. So there are some good advantages that you can consider for classful addressing. That is nothing but, it had several problems like address depletion, but it had one advantage. That is, given if you give an address, it can easily find the class of the address, since because the prefix length is always fixed. And immediately when you see, it will see the table which is divided into different classes and pick the addresses and give it to the user. So this was the advantages. Even though there was advantages, classful addressing was not used, and we moved into classless addressing. So in the next video, you will be seeing in detail about what is classless addressing. Thank you. Stay tuned for more information.